In this video we looked at how the Kubernetes deployments works. Now let's get into the hands-on. So before going into hands-on, let's understand that when Kubernetes was first released, one of the most popular demonstration of its power was the rolling update. So the term rolling update was an essential term kept in mind to develop the Kubernetes, which showed how you can use a single command to seamlessly update a running application without taking any downtime or losing request. The original demo based on kubectl rolling update command, which is still available in the command line tool, but its functionality has largely been subsumed by the deployment object. You can use the kubectl rolling update command to make use of the rollout feature of Kubernetes, but the rolling strategy is now subsumed by the deployment. So the deployment now has the rollout feature, which you can use it, which we'll now see in the hands-on. So let's go into the terminal. I will be creating a deployment. Deploy, create. So let me create a deployment of Nginx. I'm giving my deployment name as Nginx and giving the image as Nginx with a tag of 1.7.12. So now let's create this pod. Okay, I messed up in the create word. Okay, now the deployment is created. You can see the deployments using the get deployments command. Okay, Nginx. Oh, sorry, I've missed the kubectl command. Now if I look at the kubectl get deployments, you can see there's one Nginx deployment and it shows one is ready out of one available. It's up to date. Now if you check the let's before that, in the previous video we saw that in the replica set, the deployment is enclosing the replica set object. So I can show you the real time of the replica set enclosure in the deployments. You can just use the kubectl get replica set nginx thing. Okay, just type get replica set and you see that there's a replica set of nginx and then a separate id is then appended to this. So if you now just see the pods, you see that there is a nginx with the same id of the replica set, that is 77 this, and one more id is appended. So we see that the deployment has the name nginx and then the replica set is nginx with one more name id appended and a pod with the deployment name with the replica set id and then the pod id. So we see that the enclosures of pod with replica set and replica set object in deployments in action through this demo. And now let's see the label selectors by looking at the deployment object. Let me go to my GitHub. So I'll be leaving this in the description section. Let me copy this. So to see the labels in the deployments object, I'll use this command, that is kubectl get deployments, and the name of my deployment nginx, and outputting in a JSON path and giving it the template of spec and dot selector. That is, inside my spec there's a selector key and then the match labels keyword, and this gives me the labels, that is app nginx. Now with the help of this label app nginx, I can see the replica sets. So if I type kubectl get replica set and then the selector flag, and if I use this label, that is app nginx, I can see the replica sets, that is nginx 70s, this ID which we got it by previous command, that is kubectl get replica set, which is this. So we can see that with the help of the label selector we can actually get the replica set associated with the deployment object. And now let's look at the relationship between a deployment and replica set in action. So we can resize the deployment using the imperative scale command. So I will copy this and paste this command, that is kubectl scale deployments, that is nginx, and let's give it replicas of 2, and let's see what happens. So it's a deployment scale. Now if you look at the pods here, before there was only one pod, that is nginx, and now if you check the pods, you will see 2 pods because we scaled it to 2 using the deployment object. And if you see the replica sets, you see the desired is 2 and the current is 2. Before, if you see the replica set, the desired was 1 and the current was 1. So now if we set the replicas in the deployment object using the imperative command as 2, so the replica set has now a desired state of 2, so it creates one more pod to match with the desired set, that is the 2. So we see the current pod, 2 pods in action. The previous pod was the J5, that is K5 LJ5, and the created new pod was this. So we see how our deployments connected with the replica set and the pods. Now if we list, now let's do one thing, let's scale the deployment. Let's try the opposite, let's try scaling the replica set. So now let's use kubectl scale replica sets, and then I'll use this replica set name, copy this and paste that, and let me use one replica. Let me scale down the replica sets, that is scale down the pods. Now let's see what happens. So it says replica scale. Now if we get the replica sets, that is get replica sets using this label selector app nginx. we said we see that there's the desired is now 2 and it's not reduced to 1. Why is this happening? That's odd, right? Despite our scaling the replica set to 1, it still has a 2 replica set as its desired state. What's going on? So we see that Kubernetes is a self-healing system. So the top level deployment object is managing the replica set. So the top level deployment object is managing the replica set, whereas the replica set is managing the pod. But when you make changes to the replica set, that is the replica set to 1, the deployment control notices this and takes action to ensure the observed state matches the desired state. In this case, readjusting the number of replicas back to 2. But the replica set, since it was set to 1, the deployment doesn't see the replica set's object, but it's only the top down thing. So if you mention in the deployments the replicas as 2, this will only be seen in the down objects, whereas if you mention it in the replica set and if you scale it to 1, that's in our case, this deployment doesn't notice that the replicas needed is 1. So the deployment is like the top object which can see the 2 object, whereas replica set can't explicitly tell the deployment using the scale property to set it to 1. So now let's see the deployments if you are not understanding. So now let's look at the deployments. You'll see that there's 2 available in spite of giving our replica set replicas as 1. So if you ever want to manage a replica set directly, then you can do one thing is deleting the deployment object using the kubectl delete deployment command, and remembering setting the cascade flag to false, or else it will delete the replica set and pods as well. So this was about the deployments hands-on. Thank you.